In this video, I'm going to be going over MCPBA and its mechanism. And I'm going to first start off by writing how the product would look like. So basically all that happens is that double bond gets changed into an epoxide, which basically means an oxygen forms between those two bonds. So this is kind of how the reaction would look like. I would say the hardest part of understanding this mechanism is what it actually is. So an R group, which is basically a phenol that has a chlorine attached to it, but we can just write it as an R attached to a carbon, which is double bonded to an oxygen, which is bonded to another oxygen, and an hydrogen. And I'm going to draw our double bond structure there. So what basically happens is the electrons on the hydrogen get sent to this oxygen. The electrons from this bond get sent to this oxygen. One of these bonds gets sent over here to the oxygen. And it's actually going to grab one of those OHs, or one of those H's to make an OH, sorry. And you obviously have lone pairs here. And sorry, this bond is actually going to move and make a double bond with carbon. And then we're left with this important oxygen right here, where one of the bond from the double bond attaches itself with the oxygen, and then one of the pairs of electrons gets attached to the other side of the oxygen. I'm actually going to color code it so you guys see what's happening when I draw the next part. The next part you're just going to have the oxygen here. The red is from its lone pairs, and then the blue is from that double bond. And as a side product, you're going to have R, which is attached to the carbon. Now it's double bonded to the bottom oxygen and only single bonded to the other oxygen, but that oxygen, remember, has an OH on it now. And that's kind of the side product. But the main product that we really want is this. But what we can also do is, once we find and make that epoxide, we can react it with an acid, typically H3O+, and we can form anti-OH groups. So an OH group here, and an OH group here. I don't think we need to know the mechanism on the exam, but that's just how the product would look like if we reacted that epoxide in H3O+. That is basically it. That's the whole mechanism, and hopefully you guys found this pretty easy to understand.